Okay, welcome back to screencast land and our continuation of the IB course via some screencasting. So we're gonna start solving some trig equations using the unit circle, as our little heading says right there. So just jot that down. So we're going to do some. We're going to look at some equations, and we're going to look at how to solve them, and we're going to look at how how to find the solutions to them. And we're going to explore the sort of the infinite nature of those solutions. Right. So let's tuck in. Let's have a look at a question. Solve this one. Sine theta is equal to 1/2. Okay, I'm just going to leave it at that. Solve that. Okay. So fantastic if what you can do as we're going through this, if you want to pause and go ahead and explore. See if you can get ahead and see if you can, in this case, solve for theta, and then once you've got something down, come back, press play again. Just see what see how it matches up to what I'm about to say, or if you like, just listen on and take some notes. It's up to you. Okay, so in this case, look at this. What do we want? We want this angle that makes, when you take the sine of it, you get 1/2. Okay, so I reckon at this stage I'm thinking this is one of those exact values. Find the exact value of 1/2. Whenever we see these sort of numbers, and I want you to start to identify them, they're these numbers here, 1, 2, √3. So any fractions with these terms in them, and remember the other one, the 1, 1, √2, that's a terrible triangle. It's a very poor effort. So try again. There we go. 1, 1, √2, not much better. But these angles in here are 60, 30, and 45. And let's not forget to use radians as well, because we've got to get better at that. Okay, so what is my ratio opposite to hypotenuse 1/2? Where does that exist? Looks like this one here, doesn't it? Okay, opposite over hypotenuse 1/2. So 30 degrees is my solution. So I'm just going to write theta equals 30 degrees. I'm hoping that you're sort of screaming down the screencast here saying that's not all there is to it, because at 30 degrees, hopefully in the last couple of days, we've picked a few things up about this, and that is that there's a few more solutions to this, aren't there? So if we have a look at the 30 degree, so what is this saying? Sine of thing. So this is, if we go back to this unit circle, always good to go back to the unit circle, our little friend, the unit circle, there he is. Okay, so at obviously way out of scale and stuff, don't worry about that. But at 1/2, right, there's 1/2, that'll do, that's 1/2. Let's go across from there. So this is 1/2. So when my y coordinate is 1/2, that angle there is going to be 30 degrees. All right, this has got an x coordinate, a y coordinate of 1/2. But we know now that if I just extend that over, right, there's another angle here that'll also give me 1/2 for a y coordinate. So this sine of this angle here is also going to be equal to 1/2. Okay, what is that angle there? Well, that one's 30 to match that one. So this one here is 150. So let's add that to our solutions. We've also got 150. So theta's 30, but it's also 150, and you can check that. So let's do it. Don't take my word for it. Let's go back into, what am I doing here? Let's take a calculator out. Thank you. And go in and find some trig. So sine of, thank you, of 30. You can work any time you like. Thanks very much. 30. What is wrong with you? 30. Great. Alright, we've had a freeze situation here. Let's get out of here. Sine 30. Enter. 1/2. Great. I'm starting to regret using this calculator. Sine 150. 1/2 as well. Fantastic. Right, eh? We knew that already. I didn't need to do that. Okay, but there's more, isn't there? We can keep going. So I didn't. It just says solve sine theta equals 1/2. It didn't say stop at the first solution. So what about this angle? I can also make that angle by doing that, can't I? Go on 2 pi beyond. So go 2 pi, or sorry, I'm talking in radians. 360 plus 30. So 360 plus 30, that's 390. But we could also go 360 plus 150, which is 510 degrees. And we can keep going. We get 720 plus 30. We can go forever. What about, hopefully a few of you are now saying, how about the other way? Let's not just go positive direction. Let's go the other way, shall we? Let's find that angle there. That's minus 180 minus. That's minus. I'm going to in blue. I'm going to put the no, let's keep it in black. Minus 210 degrees, because now we've gone back here by minus 210. And if we kept going, if we kept on going, this is going to get really messy. The last one I'll do, go right around here, go wrap around in a negative direction to that angle there. What's that? To that line. So that's now all the way bar 330. Sorry, by bar 30. So that's minus 330. And we can keep going around and around in a negative direction as well. There are an infinite number of solutions to this equation. Any trig equation, infinite number of solutions. So we can't answer this, because we're just going to go dot dot dot. This goes on forever, right? So in reality, a question is, you're not going to get a question like that because you don't have the time. If you got this as question 1 in an IB paper, that's all you'd answer, and you still wouldn't get it right. So that'd be pretty sad. So if you go, in reality, you're going to get solve sine theta equals 1/2 for 0 to 360, for example. So you're going to be given a domain to work within, and now we can actually solve this. So we can therefore say, oh, okay, this is cool. Theta is 30 or 150, and that's about it, isn't it? We're done. We've got 2 solutions to sine theta equals 1/2. We could, but I also want to highlight that this domain could change. It could go from minus 180 degrees to 180 degrees. So that would be, wouldn't actually pick up any of the negatives. It would only pick up, the same 3150. That wasn't very exciting. We get the same results because there are actually none in this quadrant down here. We could be asked to find it in terms of radians, so 0 to 2 pi, and if we were, then we need to give our solution in radians, which would be pi over 6 for 30, and for 150 would be 5 pi over 6. So we need to reflect. It would be no point putting down here in degrees if they were in radians. That would be poor form. Okay, so there's our. Right, let's do another one. So let's solve. Let's say do this one. Let's solve tan theta is equal to, let's say, minus the square root of 3 for, let's go from minus pi to pi. Okay, so, all right, first job, again, root 3, what are we looking at there? We're looking at one of these little triangles where root 3 sits there, 1 sits there, 2 sits there. So it's this angle in here, is it not? This 60-degree angle in here. But hang on, we're in radians, so we're going to have to write that as pi on 3. So that's my angle of interest, because opposite over adjacent, root 3, done. So pi on 3, however, it's negative, isn't it? So we need to consider this pi on 3, pi over 3, or 60-degree angle, but in the negative tan quadrants. So not that one, it's positive there. Yes, good there. Not that one, it's positive there. Yes, good there. So we want pi on 3 in here. So let's do that. Let's put a pi on 3 in this quadrant here. So that would be pi on 3 in there. And we want a pi on 3. So when I say we want a pi on 3, it's that angle there with the x-axis, isn't it? So it's also this angle here, which is pi on 3. Okay, so now we need to represent those angles, but within this domain. Right, so what's this angle? So these are the two angles, this angle here. What's that angle equal to? If that's pi on 3 there, then the whole thing is 3 pi on 3. Back it off by pi on 3, that's 2 pi on 3. So that is theta equals 2 pi over 3. Now that's a solution. What about this angle here? Now that's as far as we're going to go, because our next wraparound we're going to be outside this domain. So that's in a positive direction, that's all we can manage. In this direction here, theta, you should be able to see that's just minus pi over 3. So our two solutions are theta equals minus pi over 3, 2 pi over 3. Okay, so there's our process for solving trig equations. Just a little summary. First job is this is not a calculator exercise at the moment, we're just using our exact values. So we identify what the angle is using our triangles, and then we look at the domain. Right, what are we solving for? Yeah, well, and it does vary. So we then pick out the quadrants that it works for. Now, in our second example there, tan is negative in these two quadrants. Gave them a tick. So we want angles that relate to this pi on 3 being the acute angle with the x-axis in those two quadrants. So we reflect that. In the first example, well, the first example went everywhere, but with let's pick out this one here, 0 to 360. So what we did here, we found this angle, this acute angle here, to be 30 degrees. So we picked out 30, and it was from 0 to 360, and sine is positive there and there, and it's negative here and here. So we just picked out these two quadrants, put a 30 in there, put a 30 in there. So this one was 30, this one was 150, and that was our job done for that particular question with that domain. So we need to be alert to a few different things. Hopefully you've picked up on that. I think I've rambled on for long enough. So we're ready to do exercise 11C now from the work requirements, exercise 13C, which is on page 455. I'd encourage you to have a little look at a question maybe, but certainly in class tomorrow I'll be giving you plenty of time to look over those. So I'll see you then.